Good afternoon, student. Previous lecture we will discuss about the new concept demodulations. What is demodulations? Necessity of demodulations, rectifications of demodulations, and the signals where it is present to use the detector that is known as AM detector, amplitude modulation detector. This is discussed about the earlier lecturer. What is a demodulation? The demodulation means which is recovering the audio frequency signal from the modulated carrier wave, which is known as demodulations. Necessity of demodulation, where it is used to diaphragm of the loudspeaker to contain the very hard sound will be here, so it is less sound will be created, then use the demodulations to getting the low frequency signals. So rectifications used in the demodulations when the case the modulating signal of the carrier wave to travel the 180 degree out of phase, that is a negative feedback, then upper and lower portion of the waveform travel to the inside the rectification process. When the rectification is done, the rectifier which converts the modulating signals to the demodulating signals to remove the single waveform and to get avoid to the only single waveform to the filtration. The filtration will getting the pure waveform to produce the demodulated, where the signals will present in the case of detection process to use the amplitude modulations, so it is called as the amplitude modulation detector. And today we will discuss about the very important process of the demodulations, that is known as super heterodyne receiver. Super heterodyne receiver, which is block diagram used in the case of radio receiver signals. First, we know that radio receiver. A radio receiver is a device which is used to extract the original information from the modulated carrier arriving at its input. Radio receiver, which is an electronic device which is used in the case of demodulation, extract the original informations of the modulated carrier signals to the input, so which is known as the radio receiver. Because a super heterodyne receiver is the most commonly used radio receiver. Basically, the work of the super heterodyne receiver which is used mainly, that is the radio receiver. And what is the principle of super heterodyne receiver? What is the principle? The principle of super heterodyne is the process of mixing of two signals to produce beats is known as heterodyning. There are the two signals to combine the block diagram of the super heterodyne receiver to produce the beats wave. That's beat which is known as the heterodyning, and then a receiver which makes use of heterodyning principle, that is known as super heterodyne receiver. That mixing of signals of the informations to produce the beat of wave, the wave travel to the receiver antenna, the receiver which makes the heterodyning process, so which is the principle of the heterodyne of the receiver of the demodulation process. What is the works and what is the block diagram of a heterodyne receiver? Mainly we have discussed about the first of all the principle of the super heterodyne receiver. It is the contain the local oscillator in the receiver itself, and this oscillator generate high frequency oscillations. The incoming modulated wave as first mixed with these high frequency oscillations in a spatial circuit as known as mixture. These are the super heterodyne receiver of the block diagram. To contain the 5 sections will be taken. What is the sections? First one is the RF section, second one is the mixture, and third one is the IF section, and fourth one is the audio detector section, and fifth one is the audio amplifier sections. So these are the sections of the block diagram, and these are the main important of the sections of the block diagram of super heterodyne receiver. This also sections and this also sections. What? First one is the antenna, and second one is the radio frequency, and third one is the mixture, and fourth one is the local oscillator, and fifth one is the intermediate frequency, and sixth one is the detector, and seventh one is the audio amplifier, and eighth one is the power amplifier, and last one is a speaker. This is the block diagram. RF amplifier, mixture, filter, local oscillator, IF amplifier, demodulator, audio amplifier, then get the speaker. This is the block diagram of super heterodyne receiver. What is the first is antenna. The antenna which is goes through the RF stage, then mixture. The mixture combine the local oscillator and RF stage. Then output is IF amplifier, then demodulator. The demodulator process which is used of the RF stage, and the demodulator which combine the audio amplifier and power amplifier, and last it goes to the loud speaker. This is the block diagram of the super heterodyne receiver, and this is also block diagram of super heterodyne receiver, which is the how to waveform will be created on the amplified in the case of output to produce the receiving antenna, to use the block diagram and to use the produce the waveform. And this is the block diagram of super heterodyne receiver, and this is the waveform of the super heterodyne receiver. And next one, this is also super heterodyne receiver block diagram. This is same, the used the different types of block diagram of super heterodyne receiver. Now we have discussed about one by one. The what is first one? Antenna. Antenna. What is antenna? Antenna is, you know, that is a receiving antenna, which means the radio waves which comes to the transmitter to the receiving antenna. And second one, RF, radio frequency, that is radio frequency amplifier. See the second one, RF stage is there, that is a radio frequency amplifier. And radio frequency amplifier, what works on the super heterodyne principle or super heterodyne receiver? The first of all, the RF means radio frequency, which is the antenna picks up the radio waves. RF stage, it works receivers ಇಂದ ಬರುವಂತ ಸಿಗ್ನಲ್ಸ್ ಗಳನ್ನ ಪಿಕಪ್ ಮಾಡ್ತೈತಿ, and from the various broadcasting station ಇಂದ ಬರುವಂತ ಸಿಗ್ನಲ್ಸ್ ಗಳನ್ನ ರೇಡಿಯೋ ಫ್ರೀಕ್ವೆನ್ಸಿ ಸ್ಟೇಜ್ ಪಿಕಪ್ ಮಾಡ್ಕೋತೈತಿ with the help of station selector. How, which is the station will be there, then collect of the station selector. Then decide the station is selected. The selector consists of an inductance, capacitance, parallel resonant circuit, which in the case of the selector, which is the use the and to produce the inductance and the capacitance of the parallel of the resonant circuit. The selector radio waves are very weak. When the case the antenna which emits radio waves, the signals will be weak. When the signals will be weak, in the case of the transmitting stations of the receiver of the signals too weak to produce the strong, so use the amplification. So because amplification means the weak signals will be increasing the strong signal, so amplification process is done, then these waves feeds to the amplifier and to getting the flows through the second one, mixture. So it is the mixture, it is the single input of the RF stage. So to get the better selectivity, more than the amplifying stage is used, which is works on the radio frequency amplifier stage. What is the work of the radio frequency stage is the signals of the antenna which comes to the broadcasting stations to select the signals to goes to the RF stage, but the signals will be very weak, but it is amplification process is done, then the selectivity of the signals will be strong, so it is provided to the second stage of the super heterodyne receiver. That is the second one is the mixture. The mixture which is works in the case of the mixture has the two inputs and only one input. The mixture has two input. The one input is local oscillator and the second one oscillator is FC. So FC is the carrier frequency of the radio frequency and local oscillator is the FO, that is known as FO is the local oscillator and FC is the RF stage of the amplifications. So mixture is works in the case of the mixture has two stages. There is two inputs and only one output. It mixes together the incoming radio frequency wave Fs, that is the radio frequency wave, that is Fs. So we have defined then the Fc, that is with other wave from the local oscillator, that is the frequency Fo, giving rise to some and difference to frequency like F0 plus Fc or F0 minus Fc, that is the sideband frequency ranges to that is to produce the intermediate frequency, to produce the intermediate. So we have to define the intermediate frequency is the oscillator frequency minus radio frequency. So we have to define the oscillator frequency and the minus of radio frequency. So this is the second case of the mixture. What is the works on the mixture? The mixture, it works only two inputs and only one output, and two input, that is RF stage and the local oscillator, then two FC and FO to getting the new intermediate frequency will be created, then giving the sum or difference of the frequencies to produce to avoid to the IF amplifier. And the third one is the IF amplifier. IF means intermediate frequency amplifier. Intermediate frequency amplifier which works in the case of super heterodyne receiver. The amplifier amplifies the output of the mixture which is said to be the intermediate frequency. Most of the amplification and selectivity is obtained in the intermediate frequency amplifier. Intermediate frequency amplifier which is works in the case of super heterodyne receiver. The mixture which is goes to the intermediate frequency, the most of the amplification process is done in the case of IF stage. And IF stage, the amplification process is done, then it goes to the demodulator. Demodulator which is used in the case of also known as the ಡಿಟೆಕ್ಟರ್ ನಾವು ಏನಂತಂದ್ರೆ ಡಿಮಾಡ್ಯುಲೇಷನ್ ಅಂತ. ಡಿಟೆಕ್ಟರ್ ನಾವು ಎದಕ್ಕೆ ಯೂಸ್ ಮಾಡಿದೆವು? ವಿಚ್ ಈಸ್ ದ ಸಿಗ್ನಲ್ಸ್ ವಿಲ್ ಬಿ ಪ್ರೆಸೆನ್ಸ್, ವೇರ್ ಇಟ್ ಈಸ್ ದ ಸಿಗ್ನಲ್ಸ್ ವಿಲ್ ಬಿ ಪ್ರೆಸೆನ್ಸ್ ಟು ಡಿಟೆಕ್ಟ್ ದ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಮಾಡ್ಯುಲೇಷನ್ಸ್. ಈ ಡಿಮಾಡ್ಯುಲೇಟರ್ನ ಯೂಸ್ ಮಾಡಕ ಈ ಸೂಪರ್ ಹೆಟರೋಡೈನ್ ಒಳಗೆ ಎದಕ್ಕಂದ್ರೆ the detector receives the output from the IF amplifier, separates the audio frequency signal from the IF amplifier, because the mixture and RF stage and the local oscillator to waveform will be produce the modulated waveform, because the modulated wave, that is the high frequency to the low frequency of the radio signals waves. So demodulator, which works on only remove the high frequency, that is the video signals or radio signals, to get the only audio frequency signals. So we have to use the detector in the case the IF amplifier to produce the high frequency signals, then separates the audio frequency signals from the IF amplifier and output and feeds to the AF amplifier, that is the audio amplifier ga the ಡಿಮಾಡ್ಯುಲೇಟರ ಸಿಗ್ನಲ್ಸ್ ಅನ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಿ ಆಡಿಯೋ ಫ್ರೀಕ್ವೆನ್ಸಿಗಳನ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಅನ್ನ ಎಲ್ಲಿ ಮಾಡ್ತೈತಿ ಅಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಸ್ಟೇಜ್ ಆಡಿಯೋ ಆಂಪ್ಲಿಫೈರ್ಗೆ ಕಳಿಸ್ತೈತಿ. ಈ ಡಿಮಾಡ್ಯುಲೇಷನ್ ಪ್ರೊಸೆಸ್ ಆಗಕ್ಕೆ ಕಾರಣ RF ಸ್ಟೇಜ್, ಬಿಕಾಸ್ ಡಿಮಾಡ್ಯುಲೇಷನ್ ಇಟ್ ವರ್ಕ್ಸ್ ಆನ್ ದ ರೇಡಿಯೋ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಂಪ್ಲಿಫಿಕೇಶನ್ ಪ್ರೊಸೆಸ್. ಸೊ ಆಲ್ರೆಡಿ ಟೋಲ್ಡ್ that the modulation factor in the case of demodulations to produce the radio frequency amplification, so which is combined to the RF stage and the demodulator to getting the audio frequency of the amplifier. Audio amplifier is the weak signal obtained after detection is amplified by the AF amplifier. Demodulator ಇಂದ ಬರುವಂತ ಸಿಗ್ನಲ್ಸ್ ಗಳನ್ನ ಆಂಪ್ಲಿಫಿಕೇಶನ್ ವೀಕ್ ಇರ್ತಾವು. ಸೊ ಆಂಪ್ಲಿಫೈರ್ ಮಾಡಕ್ ನಾವೇನ್ ಮಾಡ್ತೇವ್ರಿ, ಆಡಿಯೋ ಆಂಪ್ಲಿಫೈರ್ ಅನ್ನ ಹಾಕ್ತೇವೆ, which is goes to the power amplifier. Power amplifier means the signals will be very strong and to getting the output becomes the modulating signals. And the last one is the loudspeaker. Loudspeaker, which is produced to the power amplifier, that is output of the power amplifier is fed to the loudspeaker through matching the transformer. The speaker converts the electrical variation into the sound waves to speech the modulated wave caught by the area, that is the loudspeaker. Then finally we getting the sound will be produced the loudspeaker. So this is the process of the super heterodyne receiver of the block diagram. Super heterodyne receiver, the block diagram which contains these antenna, RF amplifier, mixture, local oscillator, intermediate frequency, detector and audio amplifier and power amplifier. Then finally we getting the speaker, then the output of the waves will be produced. This is the block diagram of the super heterodyne receiver, and this diagram will show the waveform of the super heterodyne receiver. The first we have to see that the antenna will be there, IF amplifier. See the waveform of the super heterodyne RF carrier, the modulated wave to carry the envelope, that is the positive and negative side of the 180 degree to getting the waveform. And second one, amplitude carrier, that is amplitude carrier means the local oscillator and mixture, which is the local oscillator and the mixture, the RF amplifier we goes to the combined to getting, that is known as the ganged tuning. We have to define the ganged tuning, that wave which is amplified carrier. The local oscillator, that is the oscillator wave means carrier wave, and the RF wave to combine the mixture which is produce the two inputs, then only get the one output. The one output is the IF carrier. IF carrier means the mixture which removes the dust particles, that is the dust particles means the waveform of the carrier and the amplitude wave carrier to remove the some waves to getting the IF carrier, the intermediate frequency carrier to produce the detecting the signals and the rectifications of the waveform, the rectifier of the amplitude carriers to produce the audio component, that is a rectification will be done, the signals will be produced, the detecting the signals which is filtrations, then output becomes the amplified audio component, that is the demodulated waveform which is detecting and AF amplifier, and it goes to the speaker, that is the waveform of the super heterodyne receiver. Then same as it is, we have to see this is also same as it is the antenna, RF stage, mixture, IF amplifier, detector which goes to the RF stage, and finally we getting the audio and power amplifier. Then these combine a local oscillator, mixture and RF stage, that is known as ganged tuning. What is the ganged tuning? gang tuning, the adjustment for the center frequency of the pre-selector and the adjustment of local oscillator are gang tuned. ಅಂದ್ರೆ ಸಿಗ್ನಲ್ಸ್ಗಳನ್ನ ಅಡ್ಜಸ್ಟ್ಮೆಂಟ್ ಮೇಲೆ ನಾವು ಮಾಡ್ಯುಲೇಟಿಂಗ್ ಡಿಮಾಡ್ಯುಲೇಟಿಂಗ್ ಸಿಗ್ನಲ್ಸ್ಗಳನ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಕ್ಕೆ ಔಟ್ಪುಟ್ ಲೌಡ್ ಸ್ಪೀಕರ್ ಒಳಗೆ ಸಿಗ್ನಲ್ಸ್ಗಳನ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಕ್ಕೆ ಅಡ್ಜಸ್ಟ್ಮೆಂಟ್ ಮಾಡಕ್ಕೆ ನಾವೇನು ಮಾಡ್ತಾನೆ ಈ ಗ್ಯಾಂಗ್ ಟ್ಯೂನಿಂಗನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅಂದರೆ the two adjustment are mechanically tied together and single adjustment will change the center frequency of the pre-selector and the local oscillator. Radio frequency amplifier, mixture and local oscillator, these three signals to complete adjustment to use the gang tuning, so which is used on the concept in the form of ganged tuning. And this is the process of the super heterodyne receiver. Oh, this is a very important of the demodulation process. The super heterodyne receiver which works on the radio receiver, and radio receiver is the most used to the super heterodyne receiver. The process to mixing of signals to produce the waveform, that is heterodyning. The heterodyne receiver of the principle that is known as super heterodyne receiver, and it works on the sections RF sections, mixture, IF sections, audio detector section, audio amplifier sections. This is also sections of the super heterodyne receiver: antenna, radio frequency amplifier, mixture, local oscillator, intermediate frequency, detector, audio amplifier, power amplifier and speaker. This is the block diagram of super heterodyne receiver. This is the block diagram and waveform of the super heterodyne receiver. This is also block diagram of super heterodyne receiver because we create the gang tuning. And what is the gang tuning? Okay, conclusion. What is the conclusion? After invention of super heterodyne, there are many inventions, but it is the best receiver of the demodulation process. So this is the process of the super heterodyne receiver. Okay, then the concept of the demodulations will be over. Okay, thank you my dear student.